We are on experiment 3, and in this experiment, the first part is, that is the experiment 3, that's color of ionic salts, right? In this experiment for part A, our aim is to determine whether an anion or a cation determines the color of a compound, right? So you have 4 different groups of compounds, and 2 of them will be colored and 2 of them will be colorless. And so the first part, we just need to visualize the salt in water to see whether they give color or not, okay? So let's say for group 1, you are given zinc nitrate, lithium nitrate, you've been given copper 2 nitrate, and copper 2 sulfate. For group 2, we have sodium nitrate, strontium nitrate, we have nickel 2 nitrate, and we have nickel 2 chloride. In group 3, you have potassium nitrate, barium nitrate, we have cobalt 2 nitrate hexahydrate, and we have cobalt 2 chloride hexahydrate. In group 4, you've been given aluminum nitrate, magnesium nitrate, hexahydrate. Don't worry about the hexahydrate part. Iron 3 chloride hexahydrate, and you are given iron nitrate nanohydrate. Okay, so you're given all these 4 groups of compounds. Start with potassium nitrate from group 3. You're just gonna put some water here. You can either put the salt first. Let's do the salt first. Just a little bit. With a pinch of it in the test tube. Potassium nitrate is the first one. The second one is barium nitrate. And this is cobalt 2 nitrate hexahydrate. Just put it a little bit. And we have cobalt 2 chloride hexahydrate. So let's put some water in it. So the first one, which is potassium nitrate, see its color, that dissolved in water. It's quite colorless, it's all dissolved. The next one is barium nitrate. It's also quite colorless. This is cobalt nitrate. You can see it's quite red. Let's look at cobalt. It's also nice red color, as you can see from here, as it dissolves, right? Among all these 4 salts, just looking at the colors they give in solution, you should be able to determine whether it's the anion in the compound that is giving the color or the cation that's giving the color by just comparing the 4, the results we will see. So we are on the next group of compounds, and we are working with group 2 right now. So we've been given sodium nitrate. Let's take some amount and put it in the test tube and let's see what color comes up. So this is strontium nitrate. It doesn't matter how much you take, you just need to see the color in solution. Strontium nitrate. This is nickel nitrate. Nickel chloride hexahydrate. It's a beautiful. You can even see the colors before we add water. Let's add water to the. So sodium nitrate, colorless. Strontium nitrate, also very clear, as you can see, no color. Nickel nitrate, very pretty, nice green color. nickel chloride, very pretty green, as you can see from here. Very good. And see there are various colors in solution. So this is all you need to do for part A. So part B of this lab, we'll be using a colorimeter, right, connected to a vernier to determine the color wavelength of light correspond to, right? So what we're going to do is we're going to use a plain sheet of paper, white paper, and we're going to place it in this colorimeter and set the wavelength to a specific wavelength. So first, close up. You see this colorimeter has 4 wavelengths: 430 nanometer, 470 nanometer, 565 nanometer, 635 nanometer. These are the 4 wavelengths that this colorimeter can measure, right? So what we need to do is want to know what color does the 430 nanometer correspond to. So in order to do that, we need to set blend to 430. You should see some lights flashing on there. Let's change it to 470 and see the color. Wow. Quite close. Let's change it to 565. Great. Right. And let's change it to 635. Yeah. Okay. So now that we know the color that these wavelengths correspond to, our next step is to go to part C. With part C of this experiment, what we are going to do is you were given 2 color solutions. The color solution in the 4 groups can be seen here. As you can see, cobalt nitrate is purple reddish, iron nitrate is orange, nickel 2 nitrate, this is iron 3 nitrate, nickel 2 nitrate is green, and copper nitrate is blue. We are going to determine the wavelength at which these colors absorb maximum. First, we need to calibrate the colorimeter. We're going to pick up the nickel 2 nitrates, which was part of your group that you use in part A. Our aim is to determine the wavelength of maximum absorbance of this nickel 2 nitrate. We're going to use the computer. We need a program called Logger Probe. You double click it on the computer. So the Logger Probe will be open. As you can see, this is transmittance, but we want absorbance. So you can double click this, and then you can change the transmittance to absorbance. And you hit OK, right? So now we are reading absorbance. What we need to do next is to calibrate our colorimeter. In order to calibrate our colorimeter, we're going to use distilled water in a cuvette. And it's very important to know that before you place the cuvette, it has a clear part and it has some opaque part, right? A part that's not that clear. So if you look at your colorimeter, you look at an arrow. Where the arrow is pointing where the light is passing through, so you place it, the clear part, directly where the arrow is pointing. So once you place your distilled water, you close the colorimeter, and then you change the wavelength to 430. Okay. Once you change the wavelength to 430, you need to calibrate. You hit by hitting calibrate. Once you hit calibrate, you see the red blinking light. Once it goes off, means it has been calibrated. And you can see the absorbance is reading close to 0. Okay. So now we have calibrated our colorimeter. We need to measure the absorbance of the nickel 2 nitrate. So we remove this still water, we place it aside, and then we take our nickel, we use the clear side facing the arrow. So we turn it like this, and we place it in the colorimeter. And as you can see, the absorbance reading directly, yeah, you can read the absorbance reading directly from the lab room. Okay. Secondly, you remove your nickel 2 nitrate from the colorimeter, and then you take your blank and you place it back into the colorimeter. This time you're going to take the absorbance at a different wavelength, which is 470. So Once we change the wavelength, we have to make sure we calibrate again. Anytime you change wavelength, you have to calibrate. So you hit calibrate, and it's calibrating until the flashing light goes off, the red flashing light goes off. So it's calibrated, and then you place your sample